In 1879, in Bradford, England, workers handling imported wool began collapsing. They developed fever, chest pain, and severe shortness of breath. Some were still working days earlier. Then they suddenly died. People called it woolsorters disease. Later, Dr. John Henry Bell proved it was anthrax. In inhalation anthrax, fluid rapidly fills the lungs. The mediastinum swells. The chest cavity fills with exudate. On dry land, patients can die as if they drowned. Anthrax is one of humanity's most stubborn microbial enemies. For a long time, people only knew it could strike sheep, cattle, and horses, then spread through wool, hides, skins, and meat. Buried in soil, it slept like ash. Disturbed, it woke again. What makes anthrax so frightening is how well it waits. It can shrink into a spore and remain quiet in soil or contaminated animal materials for long periods. Then, science found the clue. In 1876, Robert Koch revealed the anthrax life cycle and explained why it kept returning to the same pastures. Soon after, Louis Pasteur showed that vaccination could stop it before it struck. Anthrax became a major milestone in the birth of modern bacteriology and immunology. Now, let's enter the microscopic world. The anthrax bacterium itself is vulnerable. Its true weapon is the spore. When conditions turn harsh, it dehydrates, hardens, and wraps itself in 3 protective layers. That armor helps it survive boiling heat, strong acid, ultraviolet radiation, and even vacuum. It enters a dormant state, then wakes when the moment is right. Anthrax mainly harms humans in 3 forms: cutaneous anthrax, gastrointestinal anthrax, and the deadliest, inhalation anthrax. When spores are inhaled, their tiny size lets them reach the alveoli. Macrophages rush in and swallow them. But what they take in is a Trojan horse. Inside the lymph nodes, the spores wake up and release 3 toxins. Protective antigen, or PA, binds to the cell and opens a tiny pore. Edema factor enters through that pore and disrupts fluid balance. In the lungs, that can flood the alveoli and cause drowning from within. Lethal factor disables immune signaling. Together, these toxins make anthrax highly defensive, deeply invasive, and extremely deadly. Today, anthrax is far better controlled. In many cases, it is stopped before it ever reaches humans. Anthrax is a classic zoonotic disease. Most natural human infections come from sick animals, carcasses, or contaminated wool, hides, skins, and meat. So the most important defense begins in livestock. In endemic regions, vaccinating cattle and sheep is one of the key control measures. When an outbreak is suspected, farms are isolated, animal movement is restricted, carcasses are handled safely, contaminated soil and materials are disinfected, and nearby livestock are vaccinated. Many human infections are blocked at that stage. Looking back, anthrax led us from deadly outbreaks in pastures to the discovery of pathogens, and then to modern diagnosis, antibiotics, antitoxins, and vaccines. What it left behind was more than fear. It also marked one of the moments when modern medicine learned how to fight back.